Hi guys, welcome you all. This is me Venkat and welcome you all. Okay, and this is the third video of Fisher's Academy on the same title, Basic of Statistics. Hope you enjoyed this video and please like, share and subscribe my channel, Fisher's Academy. Thank you.
Good evening, friends. Now, in continuation, we have to see the probability value. P value is the probability if H naught means what is null hypothesis, where true, that the statistics test would fall in this collection of values. The smaller the p value, the more strongly the data contradicts H naught. When p value less than or equal to 0.05, data sufficiently contradicts H naught. Why probability value is less than 0.05? It is $1 million questionnaire arises for all the postgraduate students of medical, non-medical and all people. Because here our level of significance, that is alpha, is 95% or 0.05. So 95% means 0.95. So 1 is equal. 1 minus 0.95 is equal to 0.05. Suppose our level of significance is 0.01, otherwise 99% of confidence, then automatically our probability value will be less than 0.05. But default, most of the medical journals, they are following less than 0.05 because they are taking assumption alpha is equal to 0.05 or 95% confidence interval. They are applying, they are assuming. Okay, the next type of error. Type 1 error, rejecting true null hypothesis, we may conclude that difference is significant, when in fact there is no real difference. It is popularly known as p-value. Maximum p-value at node is called as a level of significance. Being serious p-value is kept low, mostly less than 5% or p is less than 0.05. Type 2 error, accepting false null hypothesis. We may conclude that difference is not significant when in fact there is a real difference. It is also called as power of the test and indicates sensitivity of the test. Not possible to reduce both type 1 and 2. So alpha error is fixed at a tolerable limits and beta error is minimized by increased sample size. Estimation of sample size. Small sample fails to detect clinically important effects, lack of power. Large sample identify of differences which has no clinical relevance. Calculation is based on not included formulas. Estimation of mean, estimation of proportions, comparisons in two means, comparisons in two proportions. Checklist. Level of significance, power, study design, statistical procedure. Minimum sample size required for statistical analysis 50. Basic theorem in statistics, central limit theorem, states that distribution of the sum average of a large number of independent identically distributed variables will be approximately normal. What is this important? Basics of any statistical procedures. What is parametric tests? These are statistical tests that makes assumptions about the parameters, defining properties. Assumptions are made out. Data follows normal distribution. Sample size is large enough for central limit theorem to lead to normality of averages. Data is not normal but can be transformed. Some situations where data does not follow normal distribution. Outcome is an ordinal variable. Presence of definite outliers. Outcome has clear limits of demarcation. test to be used. Suppose I am having scale, that means data type, scale type, nominal, and permissible statistics is mode and chi-square or chi-square test. Then ordinal, mode, median, that also chi-square test, that is a non-parametric test. Then interval, ratio, where mean standard deviation can be found out. These are the tests, t-test, students t-test, and analysis of variance, that is called ANOVA, and post hoc. After ANOVA, post hoc comparison, then correlation, then regression. And one sample t-test, independent t-test, and dependent t-test. Compares the sample mean with the population mean. This is called one sample t-test. Compares the means of two independent samples, independent t-test. Dependent t-test, that is called paired samples. Suppose if you are having hemoglobin levels of 100 patients, those who are attending a clinical trial, and the same patients after 1 month giving some intervention of iron tablets, some nutritional food, then automatically fenugreek and other supplementary items also given. Then after that 1 month, again hemoglobin in the same 100 patients will be tested, and we want to find out whether our hypothesis is there any statistical significance difference between pre and post intervention. So for that area we are not supposed to use t-test to sample, because the same patients after follow-up, after intervention tested. So that is called paired pre and post. That is why paired t-sample test will be applied. Analysis of variance. T-test difference between two means. If there are more than two means, that actually we usually used to call ANOVA as a extension of t-test, because in t-test we can do only two comparisons. Suppose if you want two means, more than two means, then going to the t-test increases the alpha and b error, which creates a serious flaw of the data and analysis. So when there are greater than two means to compare, we use analysis of variance types: one-way study effects of one factors, two-way study effects of multiple factors. Assumptions of ANOVA, here also normality and linearity. ANCOVA, it is a blend of ANOVA and regression. In other words, measures of how much two variables change together and how strong is the relationship. Latin phrase post hoc means after this. What after the event? That means one event. ANOVA is an event. ANOVA we can find out we have got a statistical significance. Then ANOVA tells whether there is an overall difference between the groups. The groups more than two variables, 3, 4, 5, 6, 7. So, but it does not tell which specific group is differed from other group. So for that, post hoc tests will be there. From that we can see where is the difference occurred between groups. Different post hoc tests. Bonferroni, Fisher's least significant difference LSD, Turkey's honestly significant difference HSD, Sheffield post hoc tests. Correlation and regression. Correlation denotes association between two quantitative variables. Assume that the association is linear, that is, one variable increases or decreases a fixed amount for a unit, increases or decreases in the other. Degree of association is measured by a correlation coefficient R. R is measured on a scale from -1 through 0 to +1. When both variables increases, then R is positive, and when one variable increases and other decreases, then R is negative. Graphically, scatter diagrams, usually independent variable is plotted against x-axis and dependent variable against y-axis. Limitation: it does not say anything about cause and effect relationship. Beware of spurious and nonsense correlation. Correlation, it is a strength or degree of association. Regression, nature of association. Example, if x and y related, it means if x changes the certain amount, then y changes on an average by certain amount. Expresses the linear relationship between variables. Regression coefficient beta types linear and non-linear stepwise. Regression coefficient gives a better summary of the relationship between the two variables than correlation coefficient. Non-parametric tests, also called as distribution free tests. We usually used to call distribution free tests because they are based on fewer assumptions. Advantages: when data does not follow normal distribution, when the average is better represented by median, sample size is small, and presence of outliers. Relatively simple to conduct tests. Actually, previously we have seen one table there. Actually, what are the situation? What is the parametric test? Now, actually, I am giving a situation characters, and I am telling what are the parametric test, what is the non-parametric test. Suppose if your data, continuous data is following parametric, that means following normal distribution, then automatically testing mean and hypothesized value one sample t-test. There in non-parametric, that means non-normal distribution, we are following sign test. Comparison of means of two groups, independent t-test. Whereas non-parametric test, we will follow Mann-Whitney test, Mann-Whitney U test. And means of related samples. That is, I told you pre and post, that is a related samples. That means the same patients will be taken one lab measures, then after intervention the same patient's hemoglobin level, that is called a means of related samples. The sample is related, so it is not independent, so then we are going for pair test. Same thing, that particular pair test values are not normal, not following normal distribution, then we are going for non-parametric test. For that equal test we are used to call as Wilcoxon signed rank test. Okay, then comparison of means of more than two groups. Usually in our general parametric we used to call as ANOVA. Same thing for non-normal distribution, Kruskal-Wallis test. Otherwise we used to call as non-parametric ANOVA. Okay, then comparison means of greater than two related groups. Repeated measures of ANOVA and Friedman's test. This is parametric test. This is Friedman test for non-parametric test. Assessing the relationship between the two quantitative variables, Pearson correlation and Spearman's correlation. Okay, that is why I have put here one table format, so it will be very easily you can understand and follow while selecting your data variables, which test you can follow. So normally it is I am talking about chi-square test, chi-square. People will tell lot of way, but it is a very most famous non-parametric test for categorical data used for analysis of categorical data. Others test, fixture exact probability test, McNemas test. Requirements of chi-square: sample should be independent, sample size should be reasonably large, maybe more than 40, because our expected cell frequency should not be less than 5. Each frequency in a ABCD, so that each cell should not be less than 5. Yates correction: if expected cell frequency is less than 5, so Yates, one statistician, he has given a new formula for correction for some expected cell frequency is less than 5. He has formulated another formula. And Fisher's exact probability cell used when sample size is small. Suppose greater than 40 we used to go for this, and less than 20 sample size, then automatically it is better to go for not to go for Yates correction and chi-square. It is better to go for Fisher's exact probability test because our sample size is small, n less than 20. And McNemas test, what is McNemas test? Same thing, it is like a paired t-test for continuous variable. For this categorical variable, this is also paired samples. That means, suppose I am observing a view of 100 people, whether they will vote for next time for Bharatiya Janata Party or others. Okay, in 2000, that means 19 January, I am taking the same 100 people. The same 100 people I am taking after 3 months. Okay, the same people. Actually, we are giving lot of inputs, current affairs, current things to those people. Then after January, I am taking one sample. I am saying some 20 people like BJP and 80 people doesn't like it. And May, after that, I have given some more information, day-to-day live up-to-dates on the same 100 people. So we are doing again survey. Their views is this time some BJP is 80 and this other people 20. Because of the influence of the events that occurred from January to March, January to April, then automatically their likings changes will be there. They are having inclined towards more than one particular party. This is paired. This is not chi-squared. So for this particular situation, we are supposed to go only McNemar's test used when there are two related samples or there are repeated measurements. So any paired samples, suppose 100 persons, those who are having diabetic, whether they are having depression or not, then after 2 months we are giving lot of counseling, other thing. So the 100 diabetic patients, 20 patients they are already in depression, they turned into 18 people turned into again normal. So it is because of the intervention, lot of counseling. So these, for this particular situation, we are not supposed to use chi-square test and Fisher's exact. We are supposed to use only McNemar's test because this is paired observations. What is relative risk? Very, very, very important factor. It is the ratio of incidence rate among exposed to the incidence rate among not exposed, used in random cohort RCT and cohort randomized clinical trial, that is called RCT, and cohort studies. Values less than 1, risk of disease is less among exposed. Value is greater than 1, risk of disease is more among exposed. Is equal to 1, equal risk among exposed and non-exposed. What is the odds ratio? Usually it represents as OR or odds ratio. Ratio of odds of exposure among the cases to odds of exposure among controls, used for rare diseases events. Used in actually relative risk in cohort studies or RCT studies, randomized clinical trial, and odds ratio usually in case control and retrospective studies. No meaning in calculating the risk of getting the disease. Suppose value is greater than 1, more among cases, less than 1, more among controls. Qualitative versus quantitative. Qualitative research seeks to confirm hypothesis. Quantitative research seeks to explore phenomena. And qualitative research, highly structured methods used. Quantitative research, semi-structured methods used. And qualitative research used closely ended numerical methods of collecting data, and quantitative research uses open-ended textual methods. And qualitative research study design is fixed, subject to statistical assumptions, and quantitative research study design is flexible, iterative, and subject to textual analysis. Qualitative research provides complex descriptions and information about issues such as contradictory behavior, belief, opinions, emotions, and relationships. Methods used are phenomenology, ethnography, grounded theory, Designs used case studies, comparative designs, snapshots, retrospective and longitudinal studies. Statistical software packages. Previously, SPSS was with SPSS Inc., one biggest company in US. Now it was acquired by IBM, International Business Machines. So another is R. R is a freeware, R Foundation. It is a freeware and the best software used in all data scientists, all software. And GenSet by VSN International, and Mathematica by Wolfram Research, Minitab, MATLAB, NIMAT Statistics, etc. These are the quantitative research. For qualitative research, Atlas T, Nuvivio, Mascuda, Nudist, Anthropac. Thank you, my dear friends. Herewith I am concluding my first video, that means introduction of statistics. Thank you very much for patiently hearing all my slides, all my inputs. Thank you, my sincere best wishes. We'll see you in the next video session. Maybe probably I'm going to take normal distribution very detailedly. So I'm preparing for that. Within 1 or 2 days, I'll come with a new video for normal distribution. Definitely it will be very much useful for any data scientist. All the best. Thank you.